So example 5 has to do with biconditional statements. So a biconditional statement is essentially combining the conditional statement with its converse. And if both of those are true, then the biconditional statement is true. So let's come up with an example here. P, right, so our hypothesis can be um, you have over a 90% in the class. So you have greater than 90%. Okay, and our conditional Q, let's do it in a different color. I'm sorry, our conclusion Q is you have an A in the class. You have an A. Okay. In order for this to be biconditional, it needs to go both ways. So we need to put if P then Q. All right, so that needs to be true. So if you have greater than 90%, then you have an A. Okay, so that conditional statement's true, right? In this class, if you have greater than 90% or 90% or greater, you're going to have an A. Maybe we should do 90% or greater. All right. Okay, and then in order for our biconditional to be true, we're going to also need it the other way. So we're going to need Q. If Q, then P. So if you have an A, so if you have an A, then you have greater than 90%. Greater than 90%. Okay, so that's going to be true too, right? If you have an A, that means you have at least a 90%, or we change it to greater than or equal to 90%. Okay, so that both the conditional statement and its converse are true. So the biconditional is true. So if we want to write our biconditional, right, bi because bi means two, so it's going both ways, biconditional. Both conditions are true. Okay, so our biconditional statement is going to be, we're going to put the arrows on both sides here. So if, and that means if and only if. So if we have the arrow, that means if P, then Q. If we have the arrow going both ways, that means P, if and only if. I think they have it written up here. P, if and only if Q. So how we would write that would be if you have an A, or you have greater than 90%. So you have greater than 90%. If and only if. So if and only if you have an A. Okay. And that biconditional is true, right? This biconditional is true because both P to Q is true and Q to P is true, right? If P then Q is true and if Q then P is true, so it's going to be true. Okay. So if both the, I don't really like how they wrote that up there. Okay, so let's look at the example real quick. We're not going to write it out. This video is already long enough, so example 5, but we'll look at their solution. Okay, so let's look at their solution here. So we have a conditional statement here. If a seahorse gives birth, then it is male. So male seahorses are the ones that give birth, not the females. So that conditional statement is going to be true. So P to Q, right? If P then Q in this case, right? That's going to be true. Okay, then we would also need to check the reverse. So if a seahorse is a male, then it gives birth. So if it is a male, then it gives birth. Okay. And good. They said, I was a little bit concerned they were going to say true there, but that's going to be false right? Because just because it's male doesn't mean it necessarily gives birth. It could be infertile. Um, it could die young or something like that. It doesn't necessarily have to give birth. So this is going to be false, right? The converse here is going to be false. Just because it's a male doesn't mean it's going to give birth. And so our biconditional, if P, or P, if and only if Q, right, is then going to be false because we need both of those to be true. We need both the conditional and the converse to be true in order for the biconditional to be true.